Hello, everyone. This is Dr. Prato. Thank you for coming to class today. Today, I will be covering application problems that use quadratic equations. Now, in mathematics, when you hear the term application problems, you should probably think word problems, and that's exactly what we'll be doing. But don't panic. This is actually going to be pretty fun, especially when you know the trick. And the trick is that the uh, quadratic equation can be rewritten a few different ways, and each way you can rewrite it gives its own special piece of information. So let's start with the standard form of the quadratic equation, y equals ax squared plus bx plus c. Now, this form is most useful when we want to find that y-intercept, also known as that initial condition, right when x is 0. What's happening when we first start the experiment. And you'll see an application of that shortly, of using this form in a word problem. The next is the vertex form of a quadratic equation, which is y equals a times x minus h quantity squared plus k. And what's useful here is that the vertex form of the quadratic equation tells us the vertex really easily. It's always going to be h comma k. Now, when we have a parabola, it can either open up or down, right? So here it opens upwards, and here it opens downwards. Well, let's look at these parabolas. Let's look at these vertices here and here. In this example, this vertex is actually at the minimum. Whatever y value this is, that's the lowest y value that this parabola takes. And here, this vertex is at the maximum. Whatever y value there is at this vertex, that is the maximum value that this parabola can take on. So in a word problem, if we're trying to minimize or maximize, we would like to find its vertex. So for example, if we want to minimize our losses or maximize our profits, we would find the vertex. The last form is the factored form of the quadratic equation, y equals a times x minus m and x minus n. It's best used when we find the x-intercepts. And in these application problems, sometimes it doesn't make sense for us to go below the y-axis. Maybe the y-axis is talking about area. Well, we don't have negative areas. So in order to know where the equation even makes sense, we might need to find the x-intercepts and say, okay, between these two values of x's, that's where the equation at least even makes physical sense. Okay, let's talk about this first problem. An object is launched from a raised platform. Its height in meters is given x seconds after the launch by the equation h of x equals negative 5x squared plus 40x plus 100. Question 1. What is the height of the platform? So you see how this is one of those initial conditions. We want to figure out how high the object is at time equals 0. So what we can do is put h of 0 in, and we get negative 5 times 0 quantity squared plus 40 times 0 plus 100. And we see h of 0 is 100. So where x is the seconds, so at 0 seconds, the object is already 100 meters above the ground. So the answer is 100 meters. So whatever's happening here, you have to go up 100 meters, and they're going to shoot some object up, and it's going to come down. All right, let's talk about the next question. What is the maximum height the object reaches? Now, the maximum height, well, that's going to be up here somewhere. We need to find the vertex. So in order to find the vertex, we need to transform this equation right here into the vertex form. And to do that, we need to, and it says right here, the hint is to complete the square. And that's exactly what we're going to do. So the first thing, let's take out a negative 5 from this equation and pull it out to the side. So negative 5, so we get x squared minus 8x minus 20. And do you remember how to complete the square? We take that b term right here, and we take b over 2, we half it, and then we square it. So here we take negative 8 over 2, and we square it. So that's going to be what? Negative 4 squared, which is 16. So that means we need to add and subtract 16 from inside these brackets. So minus 5 x squared minus 8x plus 16 minus 16 minus 20. And now we need to take x squared minus 8x plus 16, and we need to factor that. And remember, this always factors into x plus b over 2. And so in this case, b is negative 8 over 2, so x minus 4, quantity squared. And now look, minus 16 minus 20, that's just going to be minus 36. And now we can distribute this negative 5. So we get negative 5 times x minus 4, quantity squared, plus 180. So the vertex is given by 4 comma 180. And that means that the maximum height the object reaches is 180 meters. Let's move on to the next question, which is how long in seconds does the object travel until it returns to the ground? And here's the formula again. So as we've already discussed, the object starts 100 meters above the ground, it shoots up in the air, and it comes back down. Well, where does it hit the ground? Well, that would be the x-intercept. So that's when we use the final form, the factored form. And let me show you a way that I like to factor using the AC method. So the AC method is if you take the A term and the C term and you multiply the two together. So A times C is going to be negative 5 times 100, which is negative 500. What I like to do is break that negative apart and put the positive here. And then 500, that is 25 times what? 25 times 20. And 25 is 5 times 5. And 20 is 4 times 5. And 4 is 2 times 2. So you have all the factors right here. I like to write them out. Negative 1, comma 5, comma 5, comma 5, comma 2, comma 2. And what we want to do is we have to use all these factors. We need to figure out a way to multiply these factors together in such a way that that they add to be 40. Now look, if we take 5, 5, and 2, that's 5 times 5 is 25. 25 times 2 is 50. So if I make this 50x, and look what's left over, negative 1, 5, and 2, minus 10x. So you see where the minus 10x comes from? The negative 1, the 5, the 2. You see where the 50 comes from? That's the 5, and the 2. This is called the AC method, and it's really nice because it helps us factor trinomials without when the a term is other than a 1, plus a negative 5x squared. Okay, so what we want to do from here is we want to factor these terms. So what can we factor out of negative 5x squared and 50x? How about negative 5x? Then we get x minus 10. And what can we factor out of negative 10x plus 100? Let's factor out a negative 10. So we get x minus 10. And then you see how we can factor x minus 10 out from both of these terms. So x minus 10. And what's left on the inside is minus 5x minus, sorry, that's a little messy, 10. Now, when we find the x-intercept, so this is also what h of x is equal to. It's a little messy, I apologize. Let me rewrite that. H of x equals x minus 10 and negative 5x minus 10. Now, what is the height when the object reaches the ground level? Well, that's when the height equals 0. And when we have the zero property of multiplication, is if we have a times b equals 0, that means either a equals 0 or b equals 0. So first off, let's see what happens when x minus 10 equals 0. That's when x equals 10. And let's see in the second case, when minus 5x minus 10 equals 0. That's when negative 5x equals 10, and that's when x equals negative 2. Now, given these two answers, which one makes sense? Now, obviously, going backwards in time, negative 2 seconds, that wouldn't make a lot of sense, right? The only thing that makes sense is that at 10 seconds after the object starts its flight, it makes its way back down to the ground. So the answer is 10 seconds. All right, the final question I want to cover today with you is a maximization problem. This says that a rectangular enclosure is made using the wall of a barn and 80 meters of fencing. What should the length of the width of what should the length and width of the fence be to maximize the area that the fence encompasses? So what we want to do here is start off by labeling some information. Let's call this distance from here to here the width, and let's call this distance from here to here the length. So what do we know first off? We know that if we take the length plus twice the width, that should be 80 meters. What else do we know? We know that the area of this enclosure should be equal to the length times the width. So we know that something like area equals length times width. Now, from the first equation, we can solve for length. Length equals 80 minus 2w. And then we can apply that to the second equation. So we get the area equals 80 minus 2w times the width. Now let's think about this. We want to maximize the area. So here's the equation for the area. And we only have one variable to worry about, is the width. So if we could find out when this equation has the maximum area, we're almost done. So let's go ahead and simplify this. Let's distribute this. So 80 times w is 80w minus 2w times w is 2w squared. Okay. Now, again, if we want to find where this area is maximized, we need to find the vertex form of this equation. So let me rewrite this one more time. So I get minus 2w squared plus 80w. And let's factor out a 2. Let's factor out a negative 2. So we get w squared minus 40w. Now, again, we want to complete the square. So if we take that b term there, and that b term should be negative 40 over 2 quantity squared, and that becomes 200. No, it becomes 400. So that means that we have to take A equals -2 times W squared minus 40W plus 400 minus 400. So A equals -2. And then the question is, what does W squared minus 40W plus 400 factor into? Well, that factors into W minus 20, quantity squared, minus 400. And then we get the area equal to -2 times W minus 20, quantity squared, plus 800. So what's the vertex here? The vertex would be 20, 800. So that's telling us that when the width is 20, the area is maximized and we'll have an area of 200. But that's not the question. The question is what should the length and width be? So we know that the width should be 20 meters. But what's the length? The length, remember, was equal to 80 minus 220, 2W. So that's 80 minus 2 times 20, which is 80 minus 40, which is 40 meters. So the length should equal 40 meters. Okay, thank you for coming to class today. If you have any questions, you can come see me in my office or before or after tomorrow's lecture. Thank you so much for coming. Have a